Okay, AP Statistics here is section 2.1, day 2. We've already talked about percentiles and a graph called an ogive to find the location of data, like a percentage of how well you're doing among all of the other pieces of data. Well, another way to measure location is a big one. This is a monster day for us. In a distribution of data, it's the fabulous z-score. We call it a z-score. It's otherwise known as a standardized value. Standardized value. Okay, whenever you standardize something, you make them all similar so you can compare them, right? If we do anything in a standard way, we do it so that everything's the same, yeah? So a standardized score, which should say value, I'm a loser, standardized value, which is called a z-score, is interpreted, is found by the formula. Okay, so for any data value, you take any data value you have and you can turn it into a standardized value or z-score. This is our formula. Z equals, it's nice and easy, x minus the mean to figure out your deviation away from the mean, and then you divide that distance by the standard deviation. It's interpreted as the number of standard deviations that the data value is away from the mean. Now, since you just subtract x minus x bar, and then you divide by the standard deviation, you look at how bad, you guys should be embarrassed that I'm even an adult that can be a teacher. That should be the word can. You can get negative z-scores. That would mean that your data value is below the mean, right? Because if your data value is smaller than the mean and you subtract something that's bigger, you're going to get a negative, yeah? So you can get negative z-scores or you can get positive z-scores, which are above the mean. If I have a data value that's bigger than the mean and I subtract the mean, I'll get a positive value. Standard deviation is always positive. We made that happen in chapter 1. So example, put the height data from your class from yesterday in the calculator and list one and find the mean and standard deviation. Well, we've been over that a few times. I'm just going to write down what they were. X bar was 65.9 inches and the standard deviation was 4.6 inches. Now remember, that's interpreted as the value they would all be if they were all the same, or the typical height. That's another way that we say it. And the standard deviation is interpreted as the average distance that data values are away from the mean. All of these heights were on average 4.6 inches away from 65.9. Find the standardized value for a person who is, let's say, 60 inches tall. And find the actual percentile. You know what? That's not what I had in my notes at all. I've just erased it. Just be embarrassed again. I should just give up my paycheck probably. 66 inches tall is what it says. I just can't read. And find the actual percentile for that height. Okay, it goes like this. The z-score goes x minus x bar over the standard deviation. X minus x bar over the standard deviation. So what's the x? The person we're talking about. That's 66 minus the average, which is 65.9. Now look how close those two numbers are. That's the average and that's the person. So this person's height is real close to the actual average. Then I'm going to divide by 4.6, and what I should find is this isn't very many standard deviations away from the mean. That's the interpretation of a z-score. It is real close to the mean. So I put that in the calculator and I get 0.02. Almost no standard deviations away from the mean because of how close they are. Now over here I'm going to find the percentile. Okay, so I have the data in my calculator and I went and counted how many people were shorter than 66 inches. And when I went through and counted, I got 10 of them. So that's 10 out of those 27 people, and that's 37%. So we get something that's real close to the mean, real close to the mean, so it's barely away from the mean at all, but it's not close to the median because only 37% of people are less than that. You guys, that should tell you what the shape of the distribution is without even having to look at it. The median has to be bigger than this number because this is only 37% of the data below 66 inches. So the median's got to be a bigger number than that. If the mean is less than the median, isn't this skewed to the left? If the mean is less than the median, doesn't the shape have to be skewed left? You know I'm right. It has to be. put it in your calculator and see what happens. Now, find the standardized value for a person whose height is 71 inches. Now, that person is taller than the mean, so we should get a positive value. Here we go. Z is equal to 71 minus 65.9 divided by 4.6. The data value minus the average over the standard deviation. I put that in the calculator and it rounds to 1.1, which means this person is a little more than one standard deviation above the mean. Now that doesn't mean much to you right now, but as we keep talking about z-scores and standard deviations, you're going to get a feel for where something is located in the distribution as a result of how many standard deviations it is away from the mean. So look, I went and counted how many values are less than 71, and for the percentile, this is what I got. 23 of them were less than 71, and so that's an 85%. So 85% of the people in this data values are shorter than 71 inches, and this person is one standard deviation above the mean. Let's go to the next page.